Hello, and welcome to the Fulton Schools of Engineering Tutoring Center presents CSE 205 workshop. This workshop is focusing on developing classes in Java. Thank you for coming, whether you're here live or you are watching this on YouTube. I hope that you find it helpful. All right, so our agenda today, we are first going to go over the presenters and our objectives for this workshop. And then we are going to go into our actual material. We're going to go over the parts of a class. We're going to go over how to make constructors. We're going to go over how to instantiate objects. We're going to talk about class and object methods. And then we're going to touch on some inheritance. But before we get started, if you would not mind taking a second to follow the Fulton Schools of Engineering Tutoring Center on Instagram and Facebook. We post updates of the different events and tutoring opportunities that we have, and it's a great way for us to reach out and connect with the ASU student community and advertise our services. So if you are watching the video, go ahead and pause that now. I'll give you just a second if you're live to do that, and then I'll keep moving. All right, I'm going to keep moving now. All right, so today's presenters, it's just myself. My name is Roman Smith. I'm pursuing a BS in computer science here at ASU. I'm currently a sophomore, and my role is a special programs tutor in the Fulton Tutoring Center. So I get to do fun workshops like these. All right, so today's learning objectives. We're going to help you review the parts of class. You can review how to make constructors, review how to instantiate objects, review how to make and use methods in classes, and review inheritance. All right, so we are going to start with the parts of a class. This presentation is focused mainly in the Java language. That's the examples that I'm going to use, but making classes is pretty similar in other object-oriented languages like C++. So the concepts most of these concepts will also apply to other languages, which is great. So we are always going to start with the declaration of the class, which basically tells the computer, hey, this is a class. And this looks like in Java, you're going to say public class and then the name of the class. So in this example, the name is just sample. And then you're going to make an open bracket, and you're going to write the entire code within the class, and then you're going to close that bracket. So everything is contained within this declaration of the class. Next, we have our class variables. So a good way to think of this is these are the things that the class knows. So for example, we could make variables just like in any other class. You know, like in our main method, we are going to have, for example, an int, and then the name of the int is going to be example number. Now, you'll notice the private before the int, and that is unlike sometimes when we just declare variables normally within a method. We leave out that private or protected or public prefix. But the reason we do this is because we want to indicate to the program, to the computer, the access level of these variables. So public means that any variable that is labeled as public will be available to any other class within the program. Other classes can access it, modify it as they want. And then protected, which you see down here with this example string, protected string, example string. This means that only other classes that are children or inherent in the inheritance structure of the current class that we're talking about, any class derived from it, can access and change those variables that are protected, but other classes that are unrelated to the class, even if they're within the same program, will not be able to access and edit protected variables. And then the third type, the most restricting type, is private, and that means that private variables are completely inaccessible to any classes, anything outside of the current class. So those are the difference there in variables. And the variables are going to be the first thing that you basically put in your class after the class declaration. So moving on, then we have constructors. This is basically telling the computer how to make an object of your class. And we're going to talk about objects in just a second. And the kind of the syntax for these is you're going to say public because you want other classes to be able to make instances of this class. So you're going to say public and then sample name, whatever the name of your class is. It should be the same name. So the name of this class is sample. So public sample. And then within it, we are going to basically tell the computer or the program how to make an object of this class. And we'll talk about that in just a second. Cool. And then after your constructors are going to be your class methods. And unlike the variables, which is what the class knows, the methods are what the class can do, basically, or what objects of the class can do. And these are declared similarly to methods in any other class that you've seen. You're going to have the how protected it is, the access indicator, and then the return type of the method. In this example is an int because the sample method is returning some example number, so it's going to be returning an integer. And then after the return type, you're going to have the name of the method. And then in the parentheses, any of the parameters that are passed into that method. All right, and we'll get into each of these in depth. All right, so let's talk about declaration and variables. So each Java file, if you have something .java, each Java file represents one and only one public class, and vice versa. Every public class gets its own Java file. Sometimes you can have private classes within the same Java file as a public class, but we don't need to worry about that right now. We're mostly concerned about public classes. So the file name and the class name must match. So if we had a Java file called, let's see, just example.java, then our class must be called example. If they don't match, then the program won't compile correctly. So it's very important that they match. So variables are listed directly under the class name. And generally, it's a good idea to make your variables either protected or private as opposed to public, because this is for just kind of simple security reasons and to avoid like confusions in your code. It's not great practice to have your class variables freely accessed and edited by other classes, especially if you don't trust the people that you might be working on a project with. You want to make sure that your class works the way you want it to, and it can't be manipulated by other classes. Again, protected. If you plan to derive other classes from this class, you're going to want to use protected if you want those classes to inherit that variable. But if you don't plan on deriving classes from the current class, or if you don't want the derived classes to inherit any of the values or a specific value, you are going to make it private. And another thing is Generally speaking, this isn't a universal law, but generally don't initialize your variables unless you have some kind of permanent or final variable that won't change ever. But typically, you're going to initialize your variables in the constructor when you make an object of the class, which we'll talk about in just a second. All right, so here is a sample of the beginning, the declaration and the variables of a very simple Java class that I made for this workshop. It's just called animal.java. So always it's a good idea to comment your code as much as possible to clarify what you're doing, what certain things are. So in this case, I comment that I'm starting the animal class, and then I make my class declaration of public class animal. So that's the accessibility indicator, declaring it as a class, and then the name of the class, animal, which matches the name of the file. Cool, and then I have my opening bracket, and then within that bracket, I have a comment for my variables, and my variables here are a protected string that's called species, and I'm not initializing it, and a protected int called lifespan. Now I want these protected because I plan on deriving other classes from the animal class. You know, animal's a pretty generic term. You can have different types of animals. So I might want to derive the information from an animal class and put it into a more specific class, like a fish class or a giraffe class or something of that sort. And we'll talk about that in a little bit. But notice I don't initialize these variables because there isn't one final species for all animals. Animals have many different species. So that would be something that is initialized when you create a specific instance of this class as an object. So with that being said, let's talk about constructors. So constructors basically tell the compiler how to make an instance of the class, also called an object of the class. So we have two different types of constructors. We have the default constructor and the parameterized constructor. Let's start with the default constructor. So in Java, you don't have to define a constructor. If you don't define any constructors, the Java compiler will automatically make one for you, which is a handy thing about Java that isn't necessarily in other languages. But because this is kind of a weird handy thing about Java, you should be defining your own default constructors, or at least a parameterized constructor. So it's just good practice to be defining your own constructors. So the default constructor takes no parameters, and it sets all the class variables to default values. Now I put default in quotes because what these default values are can change depending on what your class is. There isn't always some kind of like universal default. But typically, if you have an integer, oftentimes the default is 0, as opposed to some random number. But again, it depends. It's definitely plausible that you could have a default set to something else. But the great thing about defining your own default constructor is you get to decide what the values are defaulted to. Now I want to talk about the this keyword, because we use the this keyword a lot in our constructors and in other methods within the class. So the this keyword allows you to edit and retrieve the variables of the current object. It's used to distinguish the property of the object as opposed to some parameter with the same name. And we'll see why this is useful in a second when we get into parameterized constructors. So the general class variables should usually be uninitialized and remain that way. So we want to use the this keyword to distinguish that we are editing editing the or accessing the information of a variable of the object itself, of the actual instance, and not the kind of generic class variable, because that wouldn't be good. We don't want to mess with those variables that we have uninitialized. And hopefully you'll see what I mean a little bit better in the example coming up. So here we have a sample default constructor. So this class, right, remember the class is called animal. So I'm saying public animal, parentheses, and notice there's no parameters within the parentheses because this is the default or unparameterized constructor. So I'm setting the species variable. I'm just setting it default to just an empty string. And likewise, I'm setting the lifespan equal to 0. So basically, if someone is calling this class or making an object of this class in a different class or in the main method, if they just say, hey, I want an animal, well, I say, oh, okay, I don't know, you didn't provide me with any specific attributes about this animal. It's just kind of a vague animal. So I'm just going to set this to kind of an empty basic default values for species and lifespan because I don't know anything more. So this keyword is not necessary in this instance since there are no parameters with the same name. However, it does not hurt anything to specify and use a consistent format in your constructors. So if you just said species equals empty string or lifespan equals 0, there's no other parameters by the same name. So it's not necessary to use this keyword, but personally I like to, just because I think it aids with the readability of your program, and it just clarifies exactly what you're talking about. You're talking about this species for this object. All right. So then we have the parameterized constructor, which takes parameters which are assigned to the object variables. So this allows the user to initialize the object and set the object's variables all at once. So as opposed to the default constructor or the unparameterized constructor, which just calls a generic type of class, and we don't know anything about the specifics of this object, so we set them all to kind of default values. The parameterized constructor gives an opportunity to provide specific details about an object, so that we can kind of give more information up front if that's something that we want to do. And you'll see what I mean in a second. So another thing to talk about is method overloading. So you can have two methods or constructors by the same name so long as they are different types or they take different parameters. So we're going to have a default constructor and a parameterized constructor by the same name, and this would be impossible except for the fact that they take different parameters. So you'll see what I mean. Cool. So this is our parameterized constructor for this, continuing this animal example. So here we have public animal, and now in the parentheses we specify the parameters that are going to be given when this constructor is called. So we're going to be given a string and an integer, and if we're not, then if we're only given one of them, or if we're given something else, the compiler is not going to like that. It's not going to let it happen. And if we're giving nothing in the constructor call, then we're just going to use the default constructor. So again, this keyword is not necessary because I called my parameters new species and new lifespan. But if I just called them species and lifespan just generically, then this would have been necessary. But again, I just think it's more readable and clear to use this keyword. All right, let's move on to how to instantiate objects using those constructors we just made. So a good way to think about a class is like a blueprint for a building or a car or some kind of physical object. It isn't the object itself, it's just the plan, like the framework for how to make something. And then the object is like the thing, the physical car or house that you actually make using that blueprint. So we are always going to instantiate objects in a different class from the class in which they are defined. So we couldn't call an animal object from within the animal class, because the object uses the class itself to make the object, so that wouldn't work. So in this case, classes kind of act like their own variables. You're going to list the class type and give the object a name, and then you're going to use the new command or the new keyword, which it's just a reference. So the object itself, or sorry, let me backtrack. The object name, the name of the object, isn't actually the object itself. It's just a reference to the actual object. And this has to do with how these things are treated within the actual memory structure of the computer. And so when we use the new command, that actually creates the object in the computer's memory. And we just attach the name to this object so that we can use the name to, edit the object in the memory. And we always want to give the same number of parameters as we defined in your constructor, in our constructors. And if you defined more than one constructor, then you can choose. So in our example, we gave, well, I think I have it on in, yeah, here we go. So so we're in our main class right now. And we're in our public static void main, the main method. And I have instantiated two objects of the animal class. Animal 1 was instantiated using the default constructor, so there's no parameters. And animal 2 was instantiated using the parameterized constructor. And you can see when I called that constructor, I inserted frog and 20 for the species and the lifespan. Cool. So we're going to do a quick little practice exercise. Shouldn't take too long, not too complicated. So look at this sample program here and think, what will the output be for this code snippet and why? And use the constructor definitions that we just went over to interpret how we are instantiating these objects. So I'll give you a second to do that, and then I'll go over what's going to happen here. All right, hopefully you've had a second to look this over and make a guess about what the output is going to be. So now I'll go over it. So, like I said before, animal 1 is constructed with the default constructor. And remember, the default constructor, if there's no parameters being passed, it's just going to set the species to an empty string and the lifespan to 0. And then animal 2 is constructed with the parameterized constructor. And so that just assigns the object to the object variables to the variables that are passed into that constructor. So when we print out the attributes of both of these, we have the animal1 species is just empty. There's nothing there. Blank string. Animal1 lifespan is 0. Animal2 species is frog. And animal2 lifespan is 20. So hopefully that makes sense based on what we just talked about. All right, now we're going to talk about different types of class methods, and two really important ones are called getters and setters. Technically, they're called accessors and mutators, but let's be real, no one calls them that unless you want to sound like some kind of fancy computer science royalty. But for most of us, we just call them getters and setters. So our class and object variables are private or protected. How do we access and edit their contents? Wasn't the whole idea of making them protected or private so that we couldn't do that? Well, yes, we wanted to make them so we couldn't edit them directly, but we want to still be able to interact with those variables from our objects. So we have methods, a method called a getter, and it's public. The return type is the type of variable that you're getting, and it doesn't take any parameters, and basically it just returns whatever class variable you want it to, or whatever the variable of the object that you're calling it from. You're going to see we'll call them from objects in just a second. So it just returns that whatever values in the variable. Setters are kind of the opposite. You can set that variable to a certain value. So there's no return type, it's just a void because it's not returning anything. You're just editing it. And the parameters taken are the type of variable you're setting. So we'll see that here. So the setter for the species is public void. I'm going to call the method setSpecies so we know what we're talking about. And it's going to pass in a string that we're calling new species. And that string is just going to be whatever you want the species of whatever object you're editing. So again, I'm going to use the this keyword. Again, it's not completely necessary, but I like to be consistent. So this species, or in other words, the species of the current object, is being set to the new species that's being passed into this method. And since these methods are within the class, we are able to edit that information, which is why we need a setter. So the getter, similarly, public stream get species, it's just going to return this dot species, the species of this object. Pretty straightforward. And then I've done the same thing for the lifespan. There's a setter and a getter for the lifespan. The only difference here is that the parameters passed in for the setter is an integer because the lifespan variable is an integer, and the getter has a return type of int instead of string. But fundamentally, they're doing the same thing. All right. So let's talk about custom methods then. So getters and setters aren't the only methods we want usually in our classes. We want to make them a bit more robust than that. So the good news is that we can define any methods we want in our classes. And methods are defined largely the same way as they are in all classes. Or, the main method, or sorry, not the main method, but, the main class. With the exception of constructors, obviously, we already talked about constructors. Their syntax is a little bit different. They're kind of a special kind of method. But yeah, you're just going to put the access indicator, public, protected, private, the return type. In this example, it's a Boolean, either true or false, and then the method name, which I've called is an animal. And obviously, the reasoning behind this, it's just kind of a dumb little example from our class. Obviously, if we're making an object that is an animal, it's going to be an animal. So if you're asking, is it an animal, then it's just going to return true. This is an animal. Obviously, in the real world or in your assignments or projects or whatever, you're going to have much more useful cases of different methods to put in classes than this. So calling methods, we've kind of gone over how to make the methods within the class. Now we're going to talk about how to call those methods from other classes. So class methods must be called in association with an object of that class. And they're called in a different class, whatever class the object that you're talking about has been instantiated in. So to do this, we use the dot operator. So what this does, you might have seen it in the previous examples. Basically, you take the object name, the name of whatever object you're wanting to call the method for, right? Because you can't just call the method for the class as a whole. Because remember, the class is just a blueprint. There's not actually anything there. It's just kind of instructions. So the object is the instantiation of that class. So you're going to call this method in relation to a certain object. So you're going to call the object name dot, just a period, and then you're going to call the method name, and then parameters in the parentheses if your method takes them. And then obviously your semicolon, which this is pseudocode, so I didn't put it in here, but you should always have semicolons or else your program won't work. So other than the object name dot part, it works just the same as calling a function within the same class, where you just have, or when I say function, I mean method. You have the method name, parentheses, and then the parameters within those. And then, yeah, the object name is only used because we're calling a method in a different class of the class of whatever the object is. Cool, so let's do a little bit of practice. What will be the output of this code snippet and why? And as before, use the getter and setter methods and the parameter, or sorry, not the parameter, the constructor methods that we talked about previously in this presentation. So I'll give you a couple minutes to think about this one, and then I'll keep moving. All right, hopefully you've had a bit of time to try and think about this one, think about what the output of this is going to be. So I'll go over it. So remember that the setter methods update the contents of the variables, while the getter methods are called, the getter methods are going to return the contents of the variables. And in this case, they're called within the print calls. And we can do this since the return types are integer and string. Nice thing about Java, you can just kind of append the return from these functions right into that string that you're printing out. It's pretty handy. So the answer here is that animal 1 species is fish, animal 1 lifespan is 55, animal 2 species is giraffe, and animal 2 lifespan is 70. And that's because, oh, we weren't using our constructors, I apologize. We were using our, the animal 1 and animal 2 from before to set the species and lifespan of these to different values. Before they were both completely different. Now they're fish and a giraffe, and they live to 55 and 70. So we use the set methods, the setters to do that, and then we use the getters in the print line statements to return those values that we just set and print them out. Cool. All right. Give me a second. All right. Let's talk about inheritance. So I'm not going to go too deep into the theory behind inheritance. I'm just going to talk more about how to actually implement it in our classes. So I'll talk about the child constructor, which is inheriting aspects of the parent class. Or sorry, I'm talking about the child class, which is inheriting aspects of the parent class. And I'll talk about the child constructor specifically. So we can make different types of animals their own class, like I mentioned it before. But we still want it to do everything the parent class does, plus more. So that's why we are deriving the parent class to the child class. So for the child, in the constructor, or sorry, in the class declaration, we want to use the keyword extends plus the name of the parent class after the declaration and before that open bracket. So this lets the compiler know that we are basically copying everything over from the parent class into this new class. And then we're going to just, change and add things on top of that as we want to. So in the constructor, we are going to use the keyword super to call the constructor of the parent. And then on top of that super call that we're going to use kind of as a method within the constructor, we are going to, add for any additional variables that we might have just for the child class. We're just going to add those onto the end. So you'll see what I mean in a second. And we can pass parameters to the super call if necessary, because the super is just the constructor of the parent. We just call it super to clarify that it is, the class that we're deriving from. So here I have a class called frog.java. And so I've said public class frog extends animal, right? Because a frog is kind of like a more specific version of an animal. So I want to copy everything I've already made in my animal class that we've been using as examples. And basically just make that the starting point for the frog class. And since I made my variables protected, they are going to be copied into the child class. Because remember, the protected variables continue to any derived classes, but just not any unassociated classes. If I had made my variables private, I would not be able to inherit them. So I'm going to add another variable just for frog. It's going to be an integer, and it's going to be the number of bumps on the frog. So I'm going to call it protected int number of bumps, and I'm not going to initialize it because it isn't an actual object yet. This is just the blueprint. And then I have my constructors here. I should have put a comment in there to clarify that. My mistake. So we have public frog, right? And then within that, we are calling super parentheses. So what this does is this just calls the parent, the animal. Basically, it would be just like calling the animal constructor, as if we just said animal parentheses. But we use super to remind ourselves that we're calling the parent, whatever the parent class of the frog class is, which we can go up and look at our extends keyword and see that it is animal. So the really useful thing about this is that we don't have to instantiate anything from the parent class if we use this super thing. All we have to do is add on the initialize the variables that are exclusive to the frog class that aren't in the animal class. And in this case, that's just the number of bumps. So we're going to say this dot number of bumps equals 0. And again, this is not necessary. I just like to be consistent. And then we have a parameterized constructor called public frog. Again, it has the same name, but that's okay since it has a different number of parameters and different types of parameters. And we want the string of the species name, an integer for its lifespan, and an integer. I just called it new number because I didn't want to make it a super lengthy name. But that's just going to go to the number of bumps. So all these parameters are being passed into the constructor for frog, but we can kind of lay off 2 of them back, kick them back to the constructor for animal by calling super again, because we've already written the code for that. We might as well use it. So we can go super and then pass the new species and new lifespan as parameters into that. But since the number of bumps is something special to this frog class, we're just going to have to say this dot number of bumps equals new number. And there you go. It's pretty much the same as the constructors before, just with the utilization of that super keyword and then the extends keyword and the class declaration. All right, so that was inheriting variables or that was constructors of child classes. Now we're going to talk about inheriting methods. So the child inherits all public or protected, but remember, not private, methods from the parent. However, we can make additional child-specific methods. We can also change the methods that already exist in the parent, but just for this specific class. It won't change the actual methods in the actual parent class. It basically copies the method from the parent class, and then we can tweak it and modify it for this specific class. And we do this using the @override tag. We're just going to type this @override before we type out our method. And this is only used for methods that have the same exact name as a method that exists in the parent class. So we're letting the compiler know that, yeah, I know that we already have this method because we inherited it from the parent, but I want it to do something a little different. So I'm going to override it. So it allows the parent method to be changed when called by an object of a child class. But again, it's not actually changing the parent method, it's changing the copy of the parent method into the child. And the access specifiers, public, protected, private, can be overridden as well, but only to make them less strict. You can't make them more strict. So, for example, a parent class, just adding on to our animal class, right? I've made a method in the animal class called public void because it's not returning anything, and then the method's called speak. So this is just going to print out animal noises. Super generic, right? Because not all animals make the same noises, but in the animal class, that's about the best we can do. We know that it's going to be some kind of animal noise. So we're just printing that out. Again, these are just kind of dumb little examples. You'll do things much more interesting and important, but this is just to see how this works. And then in the child class, we're also going to have a method. Well, the child class is going to inherit this method from the parent class because it's public. But for our frog class, we don't want it to make generic animal noises. We want the frog to ribbit because that's the sound frogs make. So we're going to say @override, and we're going to use the same method name, speak. But we're going to change it so that it prints out ribbit instead of animal noises when it's a frog. Cool. So let's take a look and do a little bit of practice. So what will be the output of this code snippet and why? And use the speak methods that we just talked about to make your guess. I'll give you a minute to do this and then I'll carry on. Yeah, Amanda, this video is recording, so don't worry about that. And then I'm going to upload it to YouTube. So you'll be able to find it there. It's going to be on the Fulton Schools of Engineering's YouTube channel. All right. Hopefully you've had a second to try and figure out what's going on here. So let's go over it. So generic animal is of animal class. So it uses the speak method from animal. So again, I made instantiated a new object of animal class and just called it generic animal, right? So the way we defined this method, the speak method in the animal class, is to just print out animal noises. So when we print out, well, when we call the speak method with generic animal, it prints out animal noises. Because we didn't actually override the parent method. We overrode the copy of the parent method within the frog class. And again, frog1 is from the frog class, so it uses that overwritten speak method because it is a frog, not just an animal. So when the speak method is called from the frog1 object, it prints out ribbit. So that is kind of a very bare bones look at how you can use inheritance in your classes. All right, so that's kind of the end of the content I have for you today. So I'm just going to go over what we reviewed real quick. We reviewed the parts of a class. We talked about how to make constructors. We talked about how to instantiate objects. We talked about how to make and use methods and classes. And then we talked about how you can inherit a class from another one and call, different methods from different inherited classes. So that is the end of this workshop. I hope it was useful if you're here in person or watching this on YouTube. If you have any questions, feel free to ask them. Otherwise, have a fantastic day.